Hi, you guys. Today I have with me problem 7.5 again. Yes, I've already done this problem before, but I used the energy method. So it says energy methods right over here. That's the process that they would like us to use to solve this problem, and I've already done this problem that way. And I mentioned in that video that I also want to do it using kinematics just to show you guys how much easier it is to use energy methods when you have a projectile type problem like this. And yeah, let's get started on it. But before we go ahead and do that, please don't forget to like and subscribe. Okay. So a baseball is thrown from the roof of a 22.0 meter tall building with an initial velocity of magnitude 12.0 meters per second and directed at an angle of 53.1 degrees above the horizontal. What is the speed of the ball before it strikes the ground? We're not using energy methods, and ignore air resistance. So remember that we can only interchangeably use energy methods and kinematics when we are not when we are ignoring air resistance for a projectile problem. B, what is the answer for part A if the initial velocity is at an angle 53.1 degrees below the horizontal? If the effects of air resistance are included, will part A or part B give the higher speed? Okay, so we're going to be solving for part A and part B because part C we already talked about in our last video. So I'm just going to cross that out. And the other thing is that I actually just went ahead and I took the diagram that I drew for the last video and I just copy pasted it onto the slide just because it's faster because we have a lot of work to get through. So, okay, let's write down all of our knowns. When we have a projectile type problem, we have to solve it in the two different components separately, right? So in the XY, in the XY, sorry, we have to solve it separately for X and for Y. And let's go ahead and just draw our coordinate system or just define like what's positive and what's negative. So I'm going to say right is positive and up is positive, meaning down is negative and I'll just write it down here so it's explicit, but down is negative and left is negative. But okay, so let's talk a little bit about projectile motion as a little refresher. So when we want to solve for projectile problems, we have to remember that there are two types of motion that's occurring. So in the X direction, right? So we have, you know, so no, sorry, that's okay. Let's start with the Y direction because that's a little bit easier to talk about, or that's more, it's not easier, actually, X is easier, but Y is more, it's harder. So we should talk about that first. So Y, usually it goes up and then it goes down, right? Or it goes up and it goes down, or it just goes down, okay? Or it just goes up, right? So either way, in this problem specifically, it follows like this type of path, right? So it starts at some speed, it goes all the way up, speed, it deaccelerates to a speed of 0, and then, it turns and then it goes back down and speeds up in the opposite direction, right? So that's the Y direction. That's what we're going to solve for. We're going to solve for this path. And then for X, all we're doing is there's no acceleration. So we're just moving from point A to point B, right? So if this is point A and this is point B, that's all we're doing. And we are just using this formula. So distance is equal to speed times time. But in this, we actually have to use the 5 kinematic equations. So that's important to note. Okay, so I did a lot of projectile motion problems in detail, so I highly encourage you to check out those if you need a more comprehensive refresher. But for now, I'm just going to go ahead and solve this. Okay, so let's write down all of our knowns in the X direction and all of our knowns in the Y direction for part A. So I'm going to try to do them in two different colors so that it's easier to follow. So let's start off with orange. Let's do Y first. So for Y, we know that we are traveling 22 meters downwards, right? So this ball, it's going to travel, its displacement is going to be downwards, right? So we're going to say it travels minus 22 meters, right? Then we have our speed, our initial speed, right? But our initial speed isn't just 12.0 meters per second, right? Because it's at an angle. So we have to account for the angle, and it's going to be just this component right over here, right? So it's going to be 12.0 sine 53.1 degrees, right? Meters per second. Gravity, right? So in the y direction, we actually have gravity, and that is minus 9.8 meters per second squared, right? And remember VI, because it's upwards, right? Because this component is upwards, it's positive 12.0 sine 53.1. And we are looking for VF, right? We're looking for VF. And in this problem, recall that we're going to have to solve this. We're going to have to solve for VFY and VFX. So let's write that down. VIY, DY, and VFY. Okay. So I talked a little bit about in the last video about how we have to solve for VFY, VFX, and then we have to use Pythagorean theorem. So that's what we're going to do. VFY is, we don't know. We're trying to solve for this, right? So we don't know. And we also don't know time. And remember how time is actually how we're going to relate this in X. And what do I mean by that? So let's write that down. So in X, we don't know this range. We don't know. Dx, no idea. VIY or VIX, we know that it's going to be 12. It's going to be this component. It's going to be 12 cos 53.1 meters per second. And T, well, we don't know what T is, right? But sorry, I'm actually doing this along as I haven't done this problem the projectile way before, but I just realized if we are looking for VFX, right, all we need is this right over here. We have VFX because in the X direction, remember how we said that this speed at point A, at point B, at any point, it's the exact same. So, V over here is equal to V over here. And the reason for that is because there's no acceleration. An acceleration is actually what changes the speed. And so if there's no acceleration, Vix is equal to Vfx, right? So guess what? We actually don't even need to think about time or dx for now. We don't even need those two things, right? So we're given that. All we need to do is solve for VFY. So let's do that. And how do we do that? Well, we have to use one of our 5 kinematic equations. We have 3 knowns and 1 unknown. So the equation we have to use is going to be this one. It's going to be VF squared is equal to VI squared plus 2AD, right? This has everything that we need. And now, because we're looking for VFY, we just have to isolate for VF. And we just plug in our values now. So I'm going to do that in green. And plus 2A is minus 9.8. And D is minus 22, right? And now let's plug in plug this into our calculator. Right? This is VFY. I just want to be very clear about this. And the answer that I'm getting is 22.87. I'm just going to double check that. Yep. Okay. So that's what I'm getting for VFY. Okay. So we have VFY and we have VIX, which is also equal to VFX. And so I'm going to actually write down what that is. That is 7.205 meters per second. Okay, so we see that VF, so VFX, in the X direction, we have this speed, and in the Y direction, it's 22.87, correct? So it's something like this. Well, actually, it's something like this, right? But the reason why we don't actually get a sign is because in this formula specifically, this is unique to this formula. When you are getting when you're solving for VF or VI, remember that because we are squaring these values, we immediately lose that information on whether or not it's positive or negative. So we kind of just have to use other methods to figure out if it's positive or negative. The math isn't going to tell us. But for us specifically, we know that it's this scenario, right? So this is the X, this is the 7.205, and then this is the 22.87. And we're trying to find VF, which is this component right over here. And I'm just going to rewrite that in red. So it's very, very obvious and very clear. And how do we get that? If we want VF, we have to get the square root of V fx squared plus VFY squared. And that is, sorry, I'm writing it out and then I'm going to plug it into my calculator. And then we'll see if we get the same answer as when we used energy methods. But just see how much more math and writing and time and thinking that took. Exact same answer. So you get 23.978 meters per second, which is literally 24.0 meters per second, like we got in our part A for our last video when we were using energy methods instead of using the kinematics, 5 equation projectile motion approach. Okay, so that's it for part A. Now, what about part B? So remember how in the last video when we were using energy, we didn't really have to even we didn't have to do the problem again or write anything down because in part A, we didn't even use the angle, but here we did, right? We did use angle, which is right over here, and we used angle right over here. So we need to account for that. So I'm going to erase this, and we're just going to redo this portion, just with 53.1 degrees below the horizontal. Okay. Oh, okay. So part B, okay, 53.1 degrees below horizontal. Okay, so now I'm just gonna go back here and I'm gonna redo the problem and just erase the parts. I'm gonna do with purple. Okay, so I'm just gonna erase 53.1, or I'm just gonna erase VIY, and we're just gonna write down what the new values are on top of what we already had before. Okay, so for VIY, if we are 53.1 degrees below the horizontal, now we're no longer positive 12 sine 53. We're actually now minus 12 sine 53.1. That's our new VIY. What about VIX? So VIX actually stays the same because it's the same exact component, right? So you can see that in the orange, it's that they're both the exact same, X component, same direction, same magnitude. So nothing changes for VIX. There we go. Same thing. Okay, so now recall how earlier on we said that Vix is equal to Vfx. Well, that's still the same, right? So the speed here is the same as the speed here, 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 because in the x direction we have no acceleration, so the speed is constant throughout the entire x path. Just the x path. The y path, no, we have acceleration. So that's not true. So this stays the same. Same. But here, well, we have a minus sign, so now we have to solve for VFY again. So let's do that. And we use this equation, right? So VFY squared is equal to VIY squared plus 2AD. And we're just going to isolate for VFY. So that's VIY squared plus 2AD. And we square root the entire thing. And for that, I'm getting let's plug in our values. So now I'm going to take a shortcut and you can go ahead and do it the long way. But remember how earlier here we put positive 12 sine 53.1. And now we're putting minus 12 sine 53.1. Now, the beauty of this equation is that it's squared, right? VIY is squared. So whether it's positive or negative, it's going to be the exact same thing, right? Like as long as the magnitude is the same, it doesn't matter what sign is here because A and D are the exact same as well. So we're going to have the same answer for VFY. And I actually forgot what I wrote before, so I'm just going to go ahead and just plug that in again. But just notice how we're going to get the exact same answer. And I am getting, I believe it was 22.875 meters per second. And I'm just going to double check that with my calculator. 12 sine 53.1, well, negative 12 sine 53.1 squared. Yep, this is the exact VFY. And then again, remember how X is this way, Y is downwards. And so now we're solving for this pink line, right? So we're going to use Pythagorean theorem, which you can do. I'm not going to go into that because I already showed you. And ultimately, our final answer, VF, which is going to be square root of VFY squared and VFX squared. That VF is 20, sorry, 23.98 meters per second. That's our VF, right? Awesome. So I just proved that you can solve this problem both ways. Kinematics, using a kinematics approach or using energy methods, and you'll get the same answer regardless, but energy methods are so much easier. So there we have it. Thank you so much for watching. If you have any questions, comments, concerns, please feel free to leave them in the comments or send me an email. Please don't forget to like, subscribe, and share, and see you next time.